Hey everyone, in this video we're going to take a look at a few applications of a normal distribution, kind of show you what a problem or a situation might look like, where you're using the z-score and that normal distribution table in order to interpret results. So here we have a problem that says the weights of newborn baby boys are born at a local hospital and are believed to have a normal distribution with a mean weight of 3,988 grams and a variance of 119,716. Now remember that variance is the square of standard deviation. So if I have a variance of 119,716, I am going to find that by taking the square root of 119,716. That's going to help me find the actual standard deviation for this problem. So in this case, the standard deviation ends up being 346. So let's take a really quick look at what I've got here. Here's my normal distribution. I know that the average is 3,988. and a standard deviation of 346. So as I'm moving along to the right, the first standard deviation would really occur at 4,334. And if I go again to the right one more time, I'd just be adding 346. Now I'm stopping there because you'll notice that if a newborn baby boy was born at the local hospital is randomly selected, find the probability that the boy will be less than 4,226 grams. So I'm finding the probability that X is less than 4,226. Now how does that work with this table? Well, 4,226 is somewhere right here. The problem is that's not right on a standard deviation. If it was right at 0 or at 3,988, I'd say 50% or less than that. If it was over here at 4,334, I would really use that empirical rule and add half of the 68% and say 84%. So I know from here is 50%. And I know from here on over is 84%. So this has got to be somewhere in between there. The calculus involved gets done through the use of our z-score. So remember, to find out the probability, I am first going to take my actual score and run it through the z-score formula. So the z-score formula says take the actual score you're looking for, in this case 4,226, subtract the average, and divide it by the standard deviation. That will give us a z-score. Typically a z-score is going to be somewhere between -3 and +3. Remember that we usually don't see many beyond 3 or -3 just because of how rare that would be. But let's take a moment and crunch these numbers together. All right, after doing that with my calculator, I came up with a decimal point of 0.6879. Right? This is my z-score, and it's really important to remember that this is the z-score because a lot of people will look at this and it looks in this case like a percentage, like 68%, and 68% almost looks like it would fit right in here, but this is not 68%. All right, and we want to find the probability that the weight will be less, so we're looking for the percentage that is less than that z-score, the z-score of 0.6879. So keep in mind, this is where typically we would have to go to our normal distribution table. They have them built into the Hawk's Learning. I'm going to grab one right here. So I've got my standard normal table up, and I'm looking for a score of 0.6879. So I'll blow this up because I can't see it then. 0.6879. Remember, z-score. I'm not looking at a percentage. I am finding 0.6. Here's 0.6. 0.687. I'm going to round that up to 0.69. So making sure that I'm in the same column here, I'm going to go over to 0.69, 75.49% or 0.7549. Right? So remember, 0.7549 is the actual probability. So z-score into that table came up with a probability of 0.7549 or 75.49%. And keep in mind, in a z-score table, it's always the amount less. So the problem in this case wanted less than 4,226. My percent is 0.7549. Now, for those of you that are working within the Hawks Learning site, the problem here also could be done with the table that is built in, remembering that I'm looking for a z-score of 0.69, and I'm going to use the positive z-score, 0.69. I don't need to translate that because that is to the left. So let's do that again, but this time let's look at a problem where we're trying to find a percentage or a probability that something happens more than. So in this case, monitors manufactured by TSI have lifespans that have a normal distribution. You'll notice I keep writing this N. When you see somebody use this notation, it's telling you normal distribution with a standard deviation of 1,500 hours and a mean lifespan of 15,000 hours. So this normal distribution has an average of 15,000 and a standard deviation, they gave it to us straight up in this case, of 1,500. So at this point, I can take that information and jump right into finding out where that fits. I always recommend graphically understanding what this looks like, so I'm going to use this as 15K right there, and then this would be 16.5. This would be 18,000 and 19.5 thousand. They want to find the probability that more than 15,884, which is probably somewhere right in here, and we're looking for what is the probability that the lifespan, or that a monitor selected at random has a lifespan that is somewhere on this side of the graph. So same steps to start out with as we did before. I'm going to use the score that I'm looking for, the actual score, minus the average divided by the standard deviation. In this case, I get 0.5893 repeating. I'm going to round that off to 0.59. You'll notice that most of our standard deviation tables, the z-score tables, were 2 decimal places. So again, z-score of 0.59. That is not the percent. At this point, I go into the standard normal table to find that z-score of 0.59. So using the one that you can get online, here is 0.5. And again, 0.59. I'm going all the way to the end of this to find 0.72240. And I'm going to write this down to emphasize. 0.72240 is everything to the left. That's this side of the problem. I want to find everything to the right. Well, 1, which is 100%, minus 0.72240, which is really 72.2%, would give me the information that I need. So I'm just going to throw that into my calculator. And I have 0.2776, right, which is 27.76% of all of this data is to the right. So keep that in mind when you're looking for something that is at most or less than, you're looking for stuff on the left. That is what naturally comes out of here. I needed to find the information on the right. So the 27.76. Typically, again, if you're doing this with something like Hawks, you can use the same strategy and say I needed to find a z-score of 0.59, but you do have to change that yourself in order to get 0.2776. I think they want it rounded off to 4. In this case, that's the information. How many of these things would be greater than 0.2776? All right, so let's take a look at one more problem. This is one of the problems that's a little bit trickier because it goes backwards. In this case, we're given a lot of information. I'm going to copy it and paste it over here so that we can talk about it first. We're given information about a normal distribution, but this normal distribution of 461 is the average, and this is a GRE verbal score. So 461 is the average with a standard deviation of 124. Now it looks like we're doing the exact same stuff that we did before. Only in the previous problems they would have said, what's percent of people get a score, let's say, higher than 480? They don't give us an actual score in this. So when I look at this z-score formula, normally I would have an actual score minus the average divided by the standard deviation, but I'm going to be missing this actual score. Instead, they give me a percentage. And if you think back to the last video where I said you take your actual score, you turn it into a z-score, and you turn that into a percentage, I also mentioned that we can do the same thing going backwards. So let's do that. In this case, we want to find students whose scores are in the top 12%. Well, that gives a little bit of an issue as well, because in order to find scores that are in the top 12%, I really have to remember that most of our tables are going to go and show us the bottom. So I'm looking for something over here. I don't know exactly where, but I'm just going to put a random line here. If this is the top 12%, I really want to find the bottom 88%. So I'm going to look for, in the z-score table, the percentage closest to 88%. And I'm not really going to worry too much. I think the Hawks Learning is always going to say stay below, like don't round up in this case. So I'll show you what I mean by that. When I'm using this table now, instead of looking through these columns on the left and across the top, I am going to be looking in the actual data to find the closest one to 88%, but I don't want to go over. So I'm going to use this 87.9%. So I've looked through here and found 87.9%. And I'm going to find the z-score that goes along with that. It's 1.1, and then if I scroll up, 1.17. So notice 1.1, attach that last thing at the end, is 7. So I have a z-score of 1.17. I'm going to plug that into this formula. 1.17 equals x minus 461 divided by 124. And at this point, just kind of going through some of the algebra to solve and figure out what that score is, multiplying both sides by 124. And then adding 461. Just kind of to cancel this out and then to cancel that out. So I'm going to crunch the numbers on that. 124 times 1.17 plus 461, and I get a score of 606.08. That 606 is now the actual score. So when they're talking about this, they say, what is the minimum score required for recruitment? If this is the average, 606 is well above average. The top 12% score higher than that. So they asked me to do this to the nearest whole number, so I'm going to do 606 as the score. That's the minimum score to get in. So in that case, you'll notice that we took the percentage, went to the z-score table to find the z-score, and then went backwards through the standard formula, the z-score standard formula. Hopefully that will help as you're taking a look at how to solve a lot of these problems. The only one that's probably still going to be a little bit tricky is to find problems where they say what percent is between two numbers. And that one I'll do in a separate video if we run across it.